Alrighty, in this video we're going to get a quick rundown of aldehydes and ketones. And in the next video we'll drop down to carboxylic acid and its derivatives. Alright, so for aldehydes and ketones, for both of them, they both contain aldehydes and ketones, both have carbonyl groups. And I always picture my carbonyls as C double bond O, and I read them with parentheses. They also contain no leaving group. We'll talk about why this is important later on. There's no leaving group. So specifically for aldehydes, aldehydes are specifically chain terminating, meaning that they're always found at the ends of chains. So ends of chains. They're named by replacing the E at the end of like the alkane parent name with al. Some common aldehydes that we'll see. Some common ones are, okay, so the first one is formaldehyde. This follows 1 carbon. 2 carbons is acetaldehyde. And 3 carbons is propionaldehyde. Now, if you notice that they just follow simple names, so this is what? Form, acetat, and then this is propionaldehyde, acetaldehyde, formaldehyde. Ketones contain a carbonyl in the middle of the chain, so C double bond O and sent in middle of chain. Named by replacing E with on. So when you're naming aldehyde and ketones as substituents, when you're naming both of them as substituents, aldehydes tend to have oxo, or they both can have oxo, and tend to have keto. Own had to do with the ending. Then we can talk about relativity to the carbonyl. So let's scroll down here. Okay, so we have a compound that looks like this. Okay, and so here we have an alpha, beta, gamma, and a delta. Okay, so they simply, here's our carbonyl. This is our source carbon that we're looking at. And the one located right next to the carbonyl carbon is always the alpha carbon. The alpha carbon is therefore connected to the beta carbon. The beta carbon is connected to the gamma carbon. And the gamma carbon is connected to the delta carbon. And that's just the simplicity of it.